Introductory Guide to the Standard Model of Particle Physics. Introduction. The Standard Model of Particle Physics is a theory that describes the fundamental particles and forces that make up the universe. This theory has been developed through decades of scientific research and experiments, and it is considered one of the most significant achievements in modern science. Fundamental particles. The Standard Model of Particle Physics describes the fundamental particles that make up our universe. These particles are categorized into two types, fermions and bosons. Fermions are particles that make up matter, and they can be divided into two types, quarks and leptons. Quarks are the building blocks of protons and neutrons, which make up the nucleus of an atom. There are 6 types of quarks: up, down, charm, strange, top, and bottom. Leptons, on the other hand, are particles that do not interact strongly with other particles. There are 6 types of leptons, There are 6 types of quarks: up, down, charm, strange, top, and bottom. Leptons, on the other hand, are particles that do not interact strongly with other particles. There are 6 types of leptons, electron, muon, tau, and their corresponding neutrinos. Bosons, on the other hand, are particles that mediate the fundamental forces of nature. These forces include the electromagnetic force, the weak force, and the strong force. There are 4 types of bosons: the photon, the W and Z bosons, and the gluon. The photon, the W and Z bosons, and the gluon. The electromagnetic force. The electromagnetic force is responsible for the interaction between electrically charged particles. This force is mediated by the photon, which is a massless boson. The electromagnetic force is responsible for many phenomena in our everyday lives, including electricity, magnetism, and light. It is the force that holds atoms together and is responsible for the chemical properties of materials. Chemical properties of materials. The weak force. The weak force is responsible for decay processes in particles. This force is mediated by the W and Z bosons, which are massive bosons. The weak force is much weaker than the electromagnetic force, which is why it is called the weak force. However, it plays a crucial role in the decay of particles and the nuclear reactions that power the sun. The sun. The strong force. The strong force is responsible for the interaction between quarks and gluons. This force is mediated by the gluon, which is a massless boson. The strong force is the strongest of all fundamental forces, which is why it is called the strong force. It is responsible for holding the nucleus of an atom together and is the force that powers nuke. Reactors. Reactors. The Higgs boson. The Higgs boson is a particle that was first predicted by the Standard Model of Particle Physics in the 1960s. It was finally discovered in 2012 at the Large Hadron Collider in Geneva, Switzerland. The Higgs boson is responsible for giving particles mass. Without the Higgs boson, particles would be massless, and the universe would be a very different place. Beyond the Standard Model. Despite its tremendous success, the Standard Model of Particle Physics is not a complete theory of the universe.